This video is lesson 18 of the Hands-on Equations learning system. And in this lesson, we're going to look at some simple algebraic equations that involve the green cube. So our first example will be x plus 3 equals negative 5. So when we're setting that up, of course, the blue pawn is still the x-man. So we're adding x plus a positive 3 because there's no sign by that 3. There's an operation in between the variable x and the number 3. And that is equal to negative 5 on the other side of the balance. To find the value of the blue pawn, the x, we can try to remove this red cube here. Of course, the problem is we don't have anything to remove it with a legal move at this point, because there's no red cubes over here and there's no green cubes over here to form a zero pair. So what we're going to have to do is we're going to have to use a different legal move to add something that will allow us to remove the red cube. And the first thing that comes to mind is add a green cube, a 3, to both sides. Now, just like with adding a red cube to both sides, or adding a blue pawn to both sides, or adding a white pawn, the star, to both sides, we can do that with the green cubes. If we add the same thing to each side, we're not changing the value of our equation. And now we can see that we have a zero pair on the left-hand side, and that zero pair has no value, so we can remove it from the balance. And we can see that x has a value of negative 8. We do need to set up our original equation to perform our check. So our original equation was x plus 3 equals negative 5. And now we're going to place negative 8 everywhere we have a pawn, the blue pawn. So this blue pawn has a value of negative 8. And when we combine that negative 8 with a positive 3, we can think of this negative 8 as a negative 5 plus a negative 3. And then we can see that a negative 3 and a positive 3 cancel each other out. So what we're left with is negative 5, which is what we have, negative 5. So our check becomes negative 5 equals negative 5. Here's another example. We have 2x plus negative 5 equals negative 7. So let's find the value of x and then check our solution. So we have two x's. We're wanting to add a negative 5. So I'll add a negative 5. And then the opposite side of the balance is negative 7. And it looks like I can take a negative 5 away from both sides. If I remove negative 5 from this side, I must also remove negative 5 from this side. When I remove 5 of the greens from that side, I'm left with 2 of the greens. So now we have 2 x's equals 2 greens, which would be negative 2. So that would mean 1x would be equal to negative 1. We'll go back and set up our original equation. 2x plus a negative 5 equals a negative 7. And then we'll substitute our value of x to perform our check. And it looks like we have negative 1 plus negative 1 plus negative 5 altogether does equal negative 7. So our check is negative 7 equals negative 7. And I want to quickly show you an alternate solution for that last problem. We could have done 2x, let me set this up again, plus negative 5 is negative 7. We could have solved this in a different way. We could have added a positive 5 to both sides. And when we add a positive 5 to both sides, we added the same value to both sides, so we didn't change the value of the equation. And now we can see on the left-hand side, there's a zero pair. So that zero pair has a value of nothing. And on the right-hand side, this negative 7 is really the same thing as a negative 5 and a negative 2. So now we can see that there's another zero pair on the right-hand side that also can be removed. And we get right back to 2x equals negative 2, which makes x equal negative 1. So that's just a different method for solving that same equation. That's probably a little bit more complicated, but it'll get you to the same solution. So to recap, in this lesson, when we are trying to solve simple algebraic equations using the green number cube, we follow the same legal moves that we have done in previous lessons, but we also have to combine our knowledge of how positives and negatives can cancel each other out, and how positives and negatives can form zero pairs to help us solve the equations.